Hello, everyone. Thank you for joining us today as we come together to learn more on how to create CI/CD DevOps pipelines for Kubernetes. My name is Houssem. I'm the program manager for Microsoft Reactor Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Houssem Dellai. Houssem works for Microsoft as a premier field engineer, focusing on Kubernetes and DevOps. He was nominated as a Microsoft MVP, Most Valuable Professional, 5 years in a row. He actively speaks at conferences, meetups, and technical discussions. He shares what he learned on the field on YouTube, and you can check out his YouTube channel on the description. Feel free to ask questions during the session. We will have regular stops to answer these questions. And also feel free to tweet about the session and tag us on Reactor Abu Dhabi. And the Twitter handle is MSFT Reactor. Make sure you adjust the playback settings to also select the highest quality since we're recording. And with all that said, I hand over the mic to our speaker to start the session.
Yeah, thank you, Houssem. So welcome again in this session. Thank you all for coming to learn more about Kubernetes, to learn about the CI/CD Kubernetes. For Kubernetes again is one of the biggest IT projects in the world today because it's not only supported by Google, the company that started the project, but today it's supported by lots of companies, lots of cloud providers like Microsoft, of course, Amazon, Google itself, and lots of other companies. They are supporting Kubernetes. So it becomes really a bit more sophisticated project, a bit more complex, and there is a lot to learn about in order to start using Kubernetes. So we have started from the last session where we have introduced the deployment to Kubernetes, how we can containerize an application, how can we deploy it into a Kubernetes cluster, where we have used the AKS, Azure Kubernetes Service, as a managed Kubernetes service hosted on Azure. And we showed you what are the basic operations for the deployment. And we have done all the deployment from our local machine. Remember, we have used kubectl from our local machine. We have run the command kubectl apply, and then we have passed our YAML files. That was a good starting point to learn, okay? But in a real world scenario, in an enterprise use cases, we don't use our local machines to deploy into a production environment. So instead, we use DevOps pipelines. And this session is all about learning all the tips and tricks for how to create those pipelines, what are the best practices, and how to implement it in using either Azure DevOps or GitHub Actions. So we'll have lots of demos today and lots of stuff to learn about it. Our agenda will have those different components. So if I can share my screen now. Let me share my screen number one, my main screen. Let me know if you can see my screen. Already seeing it? So I'm sharing my main screen. So in our agenda, we'll be using, we'll be creating actually CI/CD pipelines, either using Azure DevOps pipelines or GitHub Actions. And we'll use also, because we are talking about DevOps, and it doesn't make sense actually today to talk about DevOps if we don't talk about GitOps and infrastructure as code. So we want to automate not only the deployment of the application, but we want also to automate the provisioning of the infrastructure. And here where Terraform comes into play. So we'll be relying on Terraform to provision all the infrastructure we need for our application. This means to create the cluster itself, but not only the cluster, because when we use Kubernetes as a managed service, we will depend actually on many other services, like for instance, the ACR, Azure Container Registry, or Key Vault instance, or maybe you are also connecting to a SQL Server instance. So we'll use Terraform templates in order to automatically provision all of those resources and patch them and update them as we want, all through using Terraform. So we'll see then how we can integrate Terraform into our CI/CD pipelines. We'll see also, because we want to deploy to Kubernetes, so one way to deploy is to use the native Yammer manifest files, but we can also use Helm. So we'll learn a bit about how to create those Helm charts, how they look like, and what is when Helm comes to be important when we deploy multiple applications in our cluster. So we'll see a sample CI/CD pipeline that uses Helm also. And then we'll finish with some best practices and that I'll be sharing with you to talk about the usage of Azure Key Vault, or the use of the identity, and how to provision multiple environments that will act like the dev, test, QA, staging, pre-prod, and production environments. Good. Let's now jump in to the demo right there. So the application that I will be using for my presentation today and to run all the demo is the one available here on GitHub. So you can go check it out, and you can go to fork it or clone it on your local machine. And this app will have actually all the source code for the application. It will have also the infrastructure folder that contains the Terraform templates, the Kubernetes folder that contains the YAML manifest files. I have already cloned this project in my local VS Code instance. So here I have all the folders with all the files here. So if I open my Kubernetes folder, I'll find here my YAML files that I want to deploy into my Kubernetes cluster. And then in the infra folder, I have my Terraform files, or my Terraform templates that I'll be deploying through Azure DevOps. Great. So now I have my application is here, and it's also hosted on GitHub. So now we want to start creating the CI/CD pipeline. But before jumping into the demo, I want to take a few minutes to explain the theory or some concepts behind the CI/CD pipelines for Docker containers. So let me jump here into my OneNote, and if anyone can confirm that you can see my screen.
Yeah, it should be clear. If you zoom in a bit, and also I'll share the GitHub repo. Is it the same as the last session?
Yes, it's the same one.
I'll share it with everyone on the Q&A as an announcement.
Great, thank you. So here, let me show the workflow for you. So first of all, we are working on our machines. Okay, we have our developers working on their own machines. So from there, they will write the source code for their files, and those are the SRC source code, and then they will push this into a remote system like Git, for example. And then into Git, we'll have our application there. And after Git, we'll go to deploy this application into a Kubernetes cluster. But we'll need actually to go through some mid steps. Those steps, first of all, is to go through the build pipeline. So here we'll be talking about the build and also the release pipeline. We'll explain what each one is responsible for. So during the build pipeline, what we'll be doing here is that we'll be creating the containers itself. So here mainly we'll run the command docker build. Okay, so this will generate the Docker container itself. Then we run the command for docker push. So we'll create the container, then we'll push it where? To a registry. So here we'll add another component to this workflow, which is the registry itself. So the container that will be created here, let's see, this is our container. So it will be pushed to a registry. So let's say this is our ACR, for example, Azure Container Registry. Of course, this could be either ACR or this could be also Docker Hub, or many other container registries are available. And you can also create your own if you want to. So our container will be hosted on here somewhere, our container here. And then during the release pipeline, from there, actually, we'll take our YAML manifest files. Okay, so here we'll be running the command kube control. kubectl without error, kube control, apply -f, then your YAML manifest files. And those YAML manifest files, we have actually a reference to the container itself. So if I represent that file here, let's say that config file, it have something like here, image, and then the name of the image. Okay, let me show you actually that in VS Code, where we have seen already the Kubernetes YAML manifest files. So we have right here, for my deployment, I want to create a pod, and in that pod I have a container running. And for that container, I need to get from where to get that container actually. So here, for example, I'm using some values to be replaced. So here I'm using Azure ACR in order to retrieve a web app, a container called web app, with the version v1.value that will be specified by build.buildID. We'll see this later in our CI/CD pipelines. So here it means that my the kube control command or my Kubernetes cluster want to get that container from the Azure Container Registry from ACR. So then here we'll have another component actually, which will be our cluster. So here, say this is our AKS. So in AKS here, this file actually will run inside AKS. Okay. So the file will be stored here, and then AKS will start looking for that container, and he will try to get it from the container registry. So he will do a pull operation here to get that container and get it running inside the cluster. So the container here will live inside a pod. And this way, my app can run that container inside my AKS cluster. So this is the basic workflow for a build and release pipelines for Kubernetes. Okay, it's all about creating the image, pushing that image into a registry. Then during the release pipeline, we'll apply the YAML manifest files, and then we'll retrieve the container from the container registry. Good. We'll see how we can enrich this pipeline later with more advanced scenarios. But now let's jump now to the CI pipeline. So from here I start with Azure DevOps, and here I have already created a new project, and I have created a first pipeline here. But let me show you how we can do that. If you are new to Azure DevOps, you can go to click on New Pipelines after selecting here Pipelines, okay? And then here you'll have multiple options. First options are using, this means you will create your YAML or your CI/CD pipelines using YAML configuration files. That's what is recommended actually to do today. But for me here, I'll go to continue with the classic editor because this is better for demo, and it's more clear because it uses a visual graphical UI representation of the pipeline. So I'll go, first step to do is to specify from where to get the source code for my application. And here my app is running on GitHub, so I select GitHub, and then I can select my repository. I look for the name of my repo, which is products store on Kubernetes. I select that. Then I have here the option to select one of my branches. Here I continue with my master branch, and then click continue to select then here one of the available templates that can help me to build my pipeline. But so here we have multiple applications supported in Azure DevOps to build Android applications, .NET, Python, Maven, Java, JavaScript, and so on. Here I have container application. For that, I go to select here Docker container, hit apply. And from here we have the pipeline. So first thing to configure in our pipeline here is that we have the name of the pipeline, of course, and then from here we can select the agent that will run the pipeline. This is called either the agent or the build controller or the build agent. So it depends on how you want to call it. So in using Azure DevOps, we can actually create the agents ourselves. We can provide, or we can provision a virtual machine and install the agent on our own virtual machine. This is if we want to keep, if we want the pipeline to run on our own infrastructure. If you have some, let's say, some constraints about the security, we don't want the application source code to be deployed outside of our organization. And if it's okay for me to deploy or to get the code outside of my company, if it's secure, I can use here Azure pipelines, and Azure DevOps will provide to me some pre-built, pre-configured build agents that I can use. And there is multiple types of those agents. They can either use Windows machine, and they can also use Linux and also macOS machines, as we can see here with different versions. For our case here, I continue with Ubuntu 18.04 because I know that one, it have Docker already installed and pre-configured there. Then right here, we have the selection that we have already made when at the creation of the pipeline. Then during the agent job here, we can override some values, but here no need. Everything is set up correctly. And here we start the first task in our pipeline. Remember, this was the Docker build. So that's the first task for building the image. So here we'll use this task that uses Docker, and this task will help me to run Docker commands. So as you see here, I can run multiple Docker commands like build, tag, push, run, and so on. And for me to be able to run this, I need actually to provide my Azure subscription. So let's go to do that, because here I want to create, I want to connect to an Azure Container Registry. And note here, we not only support ACR, that's our Azure technology, but we support also Docker Hub and any other container registry if you want to. So we provide the subscription, then here we provide the container registry. So for me, I'm connected already to my Azure subscription, and I have already created some container registries. So let me show you that quickly from my from my Azure subscription. Here I have multiple resource groups, and let's see, for example, this one here. Inside this subscription, inside this resource group, I have here container registry. I have created that right here. And if you want to create a new container registry in Azure, all you need to do is to go look here for registry. And then you would have the option container registry. You select that, then you follow the template for the creation, which is just as simple as providing the name for your container registry, and then next, and that will create the container registry for you. Great. So now that I have my container registry, now I can, because I'm connected with my Azure subscription, I can retrieve all my registries in my subscription. So those are actually the ones that I have already created. I select one of them. Let's say this one, for example, or let's, oops, I want to change my mind. I'll choose test, for example. Good. Then if we go here to action, it's from here we can select the Docker command. So I continue with build, and Docker build needs a Docker file. For that, here we have this syntax here, the double star. It means look for a file called Docker file in all the folders inside my application source code. So this will look for a Docker file inside all my folders. I can, if I want, I can specify the right folder for that. So which is in my case MVC app, and inside MVC app here. So those are the files coming from my Docker, from my GitHub. Okay. So from here I go to select Docker file, and then here I have clear and only one Docker file specified right there. After that, I can here, what I can do, I can provide a name for my container. Okay, so because we want to deploy this into ACR, so we want to use the ACR name, and for that here I have a variable name called ACR, or what I can do, I can provide the name for my ACR container. So if I go here, if I go to my ACR, here we have the name of that ACR instance, which is, so let me show that clearly for you. If I go to access keys, from here we have the registry name. So I'll go to copy that value right here. And then actually we need also the login server, the name of that login server. So I replace all of this login server, then slash, and here I can put a name for my web app. Let's call this web app demo, for example. And then for the tag, we'll specify build.buildID. So this will be auto-generated by Azure DevOps, and each time we run a new build. So first time this will have the ID 1, then the next time I run the build, it will have ID 2, and so on. Great. So this is the first task now for building the container. Now we'll move to the second task, to push the container into the registry. So to do that, from here, I go to the second task, push an image. So we'll push the image into an Azure Container Registry, and then we'll go to specify where is my ACR. So I'll connect to my Visual Studio subscription here, and then from here I'll go to connect to my ACR. And for ACR, let's go to select the one that I have specified before, which was exactly test 23 test. Oops, so this should be actually 23 test ACR for AKS 23. Good. I'll go to connect to it again. So that should be 23 test, just for me to don't miss this configuration. 23 test, okay. Then yes, that's all we need in order to build and push the container. So let's go to save and queue this one, and let's cross fingers for that it works. Now here Azure DevOps started running the agent job. So first of all, it will look for an available agent in Azure. So it will look for, because it have like a collection or a group of agents, it will wait for an available agent. It found one, and it will start by checking out my source code from GitHub. So this will run a git checkout on my master branch to get all the source code inside that build agent. And now that build agent will start running the first task, which is here, build an image. So all you see here is the output from the command docker build. So you see here it's running my docker file, all these steps from my docker file, which are again available on my MVC application. So if I go to my MVC app, you would see here the Docker file that we have already shown. So last session where we said this contains all the steps required to create a container that have my application running inside that container. So we have the typical .NET commands like .NET build, .NET restore to get the packages, .NET publish, and at the end we go to run the application DLL inside that container that uses .NET 3.1, for example. So that's the generation of the image. So we see here the different steps, and this will take a few seconds. And here the build is done by that agent. Now once we have created the image, now we'll go to push that image into ACR. That's what this task will do, push an image. So as you see here, we should have, it's already preparing and it's pushing. And yes, at the end, our image will push it to ACR. So let's go to check that. So from here, I'll go to my Azure subscription. I'll go to my AKS 23 test. Okay, that's the resource group that I have used. If I go to ACR, from here, I'll go to repositories to be able to see all my repositories. And here I have my image deployed into this repository. If I click on that image, I can find the tag that was created by my build pipeline. If I click on that again, I should see here more information about the platform, which uses here Linux container and the date in which my container was created. And now I can use that container from my local machine or from AKS. So here I have the command docker pull if I want to use it. Great. So that's the first section for our CI/CD pipelines, which is to create the CI pipeline. I want to take a minute here and see if we have some questions about this. I'll check. So any questions so far?
Yes, Houssem, there are many questions on the Q&A. Starting from, will we be recording the session? Yes, we will. Past sessions are already on YouTube. You can check them out. There was a question also on the DevOps stack, tech stack that you're using to deploy.
About what was the stack for?
So what DevOps tech stack did you use to deploy AKS side of Kubernetes infrastructure?
Okay, we'll come into this actually, where we see Terraform. We'll see this just in the next demo. So we'll be using Terraform to provision the infrastructure into in Azure.
And a question from Danny, when using Azure DevOps, how do you create a service connection via CLI? And is that process automated?
Good question. Let me show you here. So actually here, yeah, thank you for mentioning that because I have skipped this. So here when I have specified, when I click here, this will populate my Azure subscriptions. And note here we have two sections actually. One here is available Azure subscriptions because this will because I'm connected to my Azure DevOps account through my email, through this email. So what Azure DevOps will do here, it will look for any Azure subscription attached to this email. Okay, and that's what is populated here. Okay, then I can, if I want, I can click choose any of these, and then I have the authorize button, and this will authorize me to connect to my Azure subscription. So this is one way to do it, but it's not the most recommended way. What is recommended actually is to use the service connection. So here, if you click on manage, this will open a new page where you have where you can go to the settings here and then service connections, and you see here I already have a service connection which is called Visual Studio Enterprise. Let me click on that again. Here I have defined a couple of those connections, and not only we have a connection for GitHub. So how I did create those connections, I can go to new service connection, and here we can connect to Azure, but we can also connect to AWS and many other technology providers. Here I have selected Azure Resource Manager. So by selecting that and click next, here we have three options for authentication. So we can either use service principal. This will, if I continue with this option, this will automatically provision the service principal. Azure DevOps will do that, and it will assign it to me to those pipelines. And if you want to do that manually, then you can select here service principal, and if you click next, from here it will ask you for your subscription ID, subscription name, service principal ID, and service principal key. Now the question is, how can you get those values? So simply for you here, if I go to here, let's clear this. You can run the command azsp create for airbag, adsp create for airbag, and with this command actually you can have this will generate for you a service principal that have an ID and a key, and then you can use those to connect to your Azure subscription. Okay, so as you see here, of course I'll go to delete this one, so don't use it. So this have the app ID and the password right here, and the tenant ID you would need to connect to your subscription. So you specify them here, and then you can this will add the connection to here so that you can use it later from your pipeline. Yeah.
Also, there was a question. Yeah, there are lots of questions. So there was a question on how we can create a YAML version of the pipeline and how that works.
Yeah. Okay. So to create, so we've seen this the creation of the pipeline using the graphical editor, but we can also use YAML pipelines to create this sort of pipelines. So let me show you that quickly here. So if I go again to my to the list of my pipelines and I try to add a new pipeline, what you would see here, so we'll select this one, create a YAML pipeline that gets its source code from GitHub. So with that, you would see here, I start by selecting a repository. I choose the one that I'm using here. And then again, we provide you here some templates for your pipelines. Here I want to create a container and deploy that container into ACR. So we have here a task that is dedicated for that. Let me choose that one. And here it will ask me for some configurations to connect to my Azure subscription and to connect to my ACR. Let's give that a second to spin up. We'll see later YAML pipelines and GitHub Actions and details. It is taking so much time to load my subscriptions because I have many subscriptions. Go. Yes, so here I select the subscription. Let's choose Visual Studio Enterprise, continue. And then here it will ask me to authenticate to my subscription. So again, this is using the non-recommended way, which is which uses the service principle by Azure DevOps. So let me specify in here. Sorry for that. Okay, connect to this one. No worry. Oops. Anyway, this will this will take so much time. Okay, so if I select this template now, this should create a simple YAML pipeline in which I can configure the tasks in it and so on. A second way to create the YAML pipelines is that we can provide you here with some help. So if you go here to your agent job, you select your agent job, you scroll up, then here you would see this button, View YAML. If you click on this, you would see the YAML pipeline that runs behind those tasks. So here you would see, for example, the variable names that I'm using. You would see the different tasks. So first task here is the Docker build. So for that, you see here this command using Docker build. Then the variables that I have specified, like the Docker file and the name of the container and so on. Then the Docker push, where here we have the different configuration that we have already specified right there. Okay, so you can start by this YAML pipeline, and then you can make some changes to it to make it work. And the same applies in your release pipelines. So this is useful if you today you have you are using the visual editor, and then you want to migrate to use the YAML pipelines, then this would really help you. Good. Okay. So, any more questions, maybe?
There was a question from Iyad. Can I configure the resources of the build agent, the RAM, the CPU, etc.?
If it's Azure hosted, if it's one of those agents, then you cannot. Okay, you don't have the hand to do that because we provide some standard configuration for these agents. But if it's your own agent, like the one that I have created here, the creation of the agent is really simple. So this one, for example, is I've created it in my own machine. You don't need the virtual machine on the cloud or a server that runs 24/24. This could be installed even on your own local machine. And yes, at that time you can configure it as you want.
Where can we run unit testing in the pipeline?
Yeah, so here let's say maybe have some unit tests in this pipeline. So there is actually two options here. Either you run your unit tests inside the Docker container itself, and then this means you would add into your Docker file, you would add another command here, .NET test, okay? And some other people prefers to run the tests outside of the container. So we have actually a task for that case. So if you look for test here, we have a task called Visual Studio Test and many other ones actually, depending on the platform you are using. And through those tests, you can give it your project that have the unit tests, and then this task will run those tests for you.
All right, one more question. What tools and steps would you suggest, including AKS infrastructure creation? Also, I'm not sure. I think he's asking about the best tools and the plugins that can be used in the process.
So yeah, if the question is about the creation, so AKS could be provisioned either using the Azure portal. So from there, you would go to create a new resource. So if I go here to my dashboard, I have always the button for creating a resource. And from there, I have here Kubernetes service. I choose to create this cluster, and here I just provide the name with some other information like the resource group and the number of the nodes and so on, and just the next, and this will create the cluster for me. Other options are using the Azure CLI command line. So through the command AKS create, you can create, provision a new cluster and configure it with all the options it have. Another interesting option, which is actually the recommended option, is to use Terraform or RM templates. And the demo today will see how to do that through Terraform. So just a few minutes and you will see the complete Terraform template for doing that.
All right, then let's proceed and we will cover the rest of the questions in the next stop.
Yeah, good. So now we have our image already deployed into the CR, into the ACR, into Azure Container Registry. Now here I've moved to another CI pipeline that I've created before, and here I have added some more steps. Actually, I want so by mentioning the tests, the unit tests will test the code itself. But here we are creating a container, we are creating or an image. So we want to test that image for any security or vulnerabilities. So for that, we can use here some open source tools available for free, like Aquasec 3V. So this is an open source project that can scan the container itself. Think of this as an antivirus that scans your machine, for example. So Aquasec will do almost that. So here I have added a task which uses the command line, and I'm using the command here docker run. I'll start the Aquasec 3V container, and then I'll tell it to scan for medium and high severity issues against my container that I have created in this pipeline. So this will run that that scan and will provide me with some medium and high critical issues. So then I'll go here to update the image tag. So again, remember when we have seen the YAML pipeline in our code. So here, if I go back to VS Code, MVC Azure. So here, the YAML pipeline we have here, actually, we are defining a special syntax for the tag of the image and also the name of the ACR we are using. Those values will be replaced by the CI pipeline, by this task exactly. So this task will look for those values. So this value here, ACR name, would be replaced by this task, but which value will it be using? Those values are provided inside the variable section. So here I have ACR name, which is ACR for AKS 21. So that would replace this value here. And then I will replace another value with build.buildID. I don't have that here because build.buildID is a predefined variable in Azure DevOps. It's Azure DevOps who will create that value for all your pipelines, and the build ID will be incremented in each build run. So we'll go to replace or to update our YAML file to have the new container tag, because here, remember, here in each time we run this pipeline, we are creating a new container with a new tag. So we want to update the tag in each time. So we want to tell Kubernetes to get the new container with the new tag. For that, we do the update here. That's really interesting, actually. And then we'll go to pass those Kubernetes YAML manifest files, and then we'll go to pass also the infrastructure files that uses Terraform into the CD pipeline. So we'll pass those different folders. Let me see a history of this run. So let's see the last run, for example, or a summary actually. So here I have the history of the runs. If I go to the last successful run from here, you will see it generated 2 artifacts. One of them is the infra folder that contains my Terraform files. And then the second one is the Kubernetes folder that contains my YAML manifest files that would be deployed into Kubernetes later. Let's go to view the console output. So here, and to replace tokens, you see here it detected 2 tokens to be replaced in our file. And here the results of the scanning the image. So from here, this will run that Docker command. And here we have the results actually. So here, to be able to see more details, I've specified a second image that is a bit old. It's 3 years old. So we will see here many vulnerability and security issues in that image. So here it gives you a detailed report about those issues. And of course, we can export this into a text file or anything we want. So here shows all of those different issues. So that's really useful, and we should always think about how we can make sure the containers we are creating are really secure. So for that, I'll add here to that step, as I said, we want to enrich our CI/CD pipelines. So I'll add here another section for scanning the image. So that we have done all of this, and we have passed the YAML and the infra files into the drop folder. Now we can start creating the CD pipeline. So let me move here to our CD pipeline. Here I have that pipeline already provisioned, but let me show you, if you want to create a new pipeline, how the creation looks like. So I'll go to open releases and a new window right here. And here I'll go to create a new pipeline, new release pipeline, again using the graphical editor. So I'll start, let's do, here we have already deployed to Kubernetes cluster. I select that template, and then let's say this is my production environment, for example. Hit save. Okay, and from here, I'll get the input, my YAML and my infra files. So here I'll select get from the build. So I'll get those files from the last successful build. So here I select the pipeline that I have created before. And then I say, okay, add that. And this will be added as an artifact that would be like the input for my pipeline, for my prod pipeline. So inside my prod pipeline, now I have one task that will run kube control command. So if I select that task, this here, it will run kube control against my AKS cluster that is hosted on Azure. So this means, again, I need to connect to my Azure subscription. And for that here, I need to provide a service connection to it. So let me check. So let's go to, if I don't see any, I can provide here a new Azure subscription, and note here other authentication methods to authenticate to our IKS cluster or to any other Kubernetes cluster is actually, you can use here the kube config file, which is the file that you can find in your local machine, if you are already connected from your local machine, or you can create a service account, or you can also create a service principal through Azure subscription that will have access to all of your resources. Good, I don't want to continue with that. That will take a few seconds. And here then we can specify the command to use with kube control. So remember here we want to create a new application. For that, you should either use the create command, but here, maybe the second time you run the pipeline, the create command will not work expected. It might have some issues because it is thinking that it would create new resources, but those resources could be already existing in AKS. So for that, we should use the command apply. And then we can specify here some configuration files. And here where I'll be using my YAML files. So if I go to the artifacts, to the generated drop folders from here, I don't see it now, but from here you can get your YAML files from there. Then you apply those files, and that should be all. Great. So this is the basic CI or CD pipeline to deploy an application into Kubernetes. But here, let's say for now, we don't have a Kubernetes cluster that is created. Okay. So for that, I'll be using Terraform first in order to provision the infrastructure. So let me leave this one, and let me go back to my to the pipeline that I have created before. So here, let's go to the dev environment. And what we want to do here with Terraform is that we want to provision the infrastructure first. So this AKS cluster, and with that cluster, maybe you want to add also ACR. Okay, so those are the two resources we want to create. So we have AKS, ACR, and maybe we are connecting to a SQL instance. Maybe that AKS or that my pod wants to connect to a SQL database, SQL Azure, for example. So I go to create this infrastructure for my application. And then, as I said, we'll be using Terraform. So the Terraform templates will be included inside the application source code. So this means they will live somewhere right here in my application source code. And those are templates. Okay, this is code that contains a description about those different resources. So it have a section that will create ACR, another section that will create AKS, and another section for creating the SQL instance, for example. And this file, it's typically call it main.tf. Okay. So when we use Terraform, it will create an AKS cluster. Okay, for example. So we need to give it the name of that ACR cluster, and we need to give it also the name of all the resources that needs to be created, like ACR and SQL. So for that, we have typically a second folder that is our second file that is called variables.tf. This will contain, for example, some information like AKS name. And here we can provide a value. And it would have something like ACR name. And here a value. Okay. So that's the basics for Terraform. Then Terraform have its own command line to run to deploy this this configuration or this infrastructure. So the command is typically Terraform Terraform init, then Terraform plan, then Terraform apply. So Terraform init it's just like Git, something like Git init. So it will download your providers and it will get all the modules used in your template. And then Terraform plan, this will check for the configuration on your Terraform. So it will tell you, for example, what are the resources that will be created. So it will detect you want to create ACR, AKS, and SQL, and then using Terraform apply, the creation will, or the provisioning will start then. Okay. So we want to run those different commands during the release pipeline in order to provision the infrastructure prior to deploying the application into AKS. So let's take a look here at a real Terraform template. So let me go back to my VS Code, and then I'll go to infra folder, which is here the one that contains my Terraform files. So first, let's see the main.tf file. So here I'm using Azure RM to say here I want to use Terraform to deploy into Azure, because Terraform can also deploy into AWS or Google Cloud or your own infrastructure and to many other cloud providers. Here I want to deploy into Azure, and I am specifying the version, the supported version for Azure RM. And then here, because I want to create resources into Azure, so each resource should have a resource group. So first of all, I'll be creating a resource group to host all of those resources, my AKS, ACR, and the SQL instance. Then I start by creating the Kubernetes cluster, which I call it here Kubernetes. The cluster would have a name, and from where I get that name, so note here I'm using var dot. This means there is a Terraform file called variables.tf that have a value cluster name. If I go to terraform.tf, I should here find cluster name, which is the variable right here, and it have a default value AKS Kubernetes 2022. So that would be the value taken by my Kubernetes cluster. My Kubernetes cluster will be hosted inside the resource group that I have specified here, and note how we are referencing that resource group. So I'll get its RG and its location, and then the resource group name that would host my AKS. Kubernetes have multiple versions. Here I'll go to specify the latest version available today, which is 1.17.3. And then because in AKS we can mix and match between Linux and Windows virtual machines, here I'll choose for my default node pool to have multiple standard DS2 v2 Linux machines. And here I specified I want to use the system assigned managed identity. Note here I can also use the service principal if I want to. And more configuration for my AKS cluster, like enabling airbag, which is a highly recommended option. For network profile, I can either use Calico or Azure policy. And yeah, we have lots of options there. So that was the creation for AKS. Now to create ACR, so we have a resource called Azure RM Container Registry. I'll call that ACR. I'll give it a name, again specified on the variables.tf file, which is the value right here. I choose the SKU option, which will be here standard. I'll disable the admin, and then I'll go to create the SQL server. So we have Azure RM SQL Server. We provide the configuration like the login and the password for that SQL server, and then I create the storage account to host my database, and then I create the database itself. So the database will be attached to a server host name, which would be here the one that I'm referencing and is the one that I have created here. So we can specify dependencies in Terraform. Then we can add some firewall rule to our database to give it to let it to accept all connections from any IP address if we want to. Good. So this is our Terraform. Template. Now we want to deploy this template in our CD pipeline to create the resources described in that template. So for that, I'll go back to Azure DevOps and note here how I'm using those Terraform tasks to provision that infrastructure. This task is available if you go to search for Terraform. You should see that task created by Microsoft Corporation, and there is lots of other tasks. If you don't see it, then it means you need to install it from the marketplace. Then you would be able to use it right here. But note, first thing I'm doing here is installing Terraform on the build agent. And this was one of your questions, can you configure the agent as you want? So you cannot change the RAM and the CPU, but you can install additional software on that agent. And that's what I'm doing here, because this build agent that I'm using, which is here Ubuntu 18.04, doesn't have by default Terraform installed. So instead, I'm using a Terraform tool installer to install a specified version of Terraform into that agent. Then I'll be able to use the Terraform command. So first command I run here is the Terraform init. So again, I should give it what is the where I want to deploy, either into GCP, AWS, or to Azure. I want to deploy to Azure, so I select Azure RM. Then I specify the command I want to run here, which is the Terraform init. So I say init, and then I'll give it the folder that contains my infrastructure, which is the /infra, and we have, remember, we have passed this as the input pipeline here from the CI pipeline. And then we need to connect to our Azure subscription. So again, here I'm specifying my Azure subscription, and then the name of the resource group. And note here, those are variables that I have already added in my pipeline as variables. So here we have the Azure subscription, the name of that subscription, the Azure resource group, and so on. Let me come back to the tasks. So once we have specified those different variables, here I'm using a container, and container here doesn't mean Docker container, but this means the container inside the storage account. Why I'm using this? That's actually, if I go back to here, Terraform, each time it needs to update a resource into Azure, it needs to know what was already the previous configuration. Okay, so it needs to store that state for my existing infrastructure, and there it will use what we call today as the TF state. So that is TF state, and that's actually a file that describes the state of my infrastructure that is created in Azure. So that state should be persisted, actually. This is important. And we cannot persist it inside the build agent, because Azure, each time it will give me another build agent. And at the time when I'm finished with my build agent, Azure will go to reset that agent. It means it will remove all the files that I have created in that agent. So I need to save it in somewhere else, and there, what I'll be using the Azure container in order to save that file. So if I go back here to my Azure subscription, I can show you for my app infra, for example. So I have already created a storage account. It's this one right here. And to that storage account, I have already created a container. So if I go to containers right here, I'll see here a file called app container tf state. This is the name of the container, and in here I have a file with the extension tf state. So that's the file used by Terraform to save the state of my existing infrastructure. So from here we can see the information, some useful information about the infrastructure that I have already created. So here we see, for example, the ACR, the current configuration of ACR, okay, and the current configuration of my Kubernetes cluster and so on. So later when I want to update my infra, Terraform will go to see what is existing in that TF state, will perform a diff operation to detect only what should be changed in my configuration, and will apply only that modification because it uses the DSC, what we call is desired state configuration. So we give it how we want our infrastructure to look like, and Terraform will do all its magic to make that state as the actual configuration. And so to create that storage container, I have already here, I'm already using tfstate.sh script. This script that I can show you right here. So this is a shell script that will use some commands like creating the resource group, creating the storage account, and then it will create the it will retrieve the key, and then it will create the container inside that storage account, and then from there this would be used by Terraform to save the tf state file. Great. So after that, I run the other commands to validate the syntax of my Terraform templates. Then I run the command Terraform plan. This one will perform the diff, and it will show me what are the changes that will be made to my cluster. Then Terraform apply in order to start provisioning the infrastructure. Then after that, now I have, it means now I have my AKS, I have my ACR already provisioned, so I start deploying my application, and here I'll be using kube control apply-f, then my YAML manifest files. So note here how we have configured this task. So first of all, it would it would use a service connection, which is my Azure subscription. It will connect to the resource group that we have specified. So here I'm using those variables to share the name of the resource group between the Terraform template and AKS, because Terraform template will create the resource inside a resource group, and here to help me to retrieve that resource group, I don't need to write it again, but here I'm using a variable name, which is pre-configured. I'll connect to my AKS cluster provided with AKS name, and remember those are the values specified right here where we have AKS name and AKS resource group. After the connection is done successfully, now I can run the command apply, and from here I run the apply command and pass to it the YAML Kubernetes YAML manifest files. Great, and of course here I have also replaced some tokens in my infra files for my Terraform template, because remember when we have seen the variables, maybe I want to change some of those variables, okay? Because I want to deploy into multiple environments. I have dev test and the prod, and the ACR name, this means I will deploy 3 clusters, so they should have a unique name, okay? So here this name should be unique, and the same applies for the ACR. So for that I have somewhere, yeah, an ACR name that should be unique. So I can override those variables by another file, which is the terraform.tfvars. So here I'm taking that ACR name and some other values, and I want to override them. So I'm using again here the double underscore. This means they will be replaced by Azure DevOps. So they will be replaced by a variable name called ACR name. ACR_name. That value will come from the list of variables described here. So it will be replaced by this one, which have the value ACR for AKS. Then I'm adding a suffix to here. What that suffix is? So that suffix is the one provided here. So it will have the value 2023, and I will add also the release.environment name. What this is remember in our pipeline we have dev, test, and prod. The release.environment name is the name of the environment. This means here when I deploy that from inside my dev environment, that would be replaced by dev, and then by test if I run that from my test environment. So this will help me to get 3 different names for my from my 3 different ACR instances. First ACR instance will have embedded in its name the dev keyword, then test, then prod. So let me show you that in my Azure subscription. So if I go back here to my list of resource groups, you would see here that I have actually multiple resource groups. So let me refresh this for a second. I have here AKS 23 dev, prod, and test right here. Each one of those resource groups would have different resources with different names. So note here all of them, they have 23 and the dev attached to their names. That's to help me to create unique names. Of course, this is one strategy, and you can also use some other strategies with Terraform. So what you can do, for example, you can specify another tf-vars file here. You can specify 3 files, a file that will be used in your dev environment, a second file that will be used in test, and another one that could be used in your production environment if you want to. Good. So now that we have deployed the application into AKS, from here we go to scan our AKS cluster. So again, we want to add more security, we want to add more tests to make sure that everything works as expected. So here I'm using Kube Advisor, which is a Microsoft open source project that will run a container called Kube Advisor. This one actually will check if in your AKS, in your Kubernetes cluster, you are creating resource limits for each of your pods. So I can show you here one of the last deployment that was done successfully. So from here, if I go to dev, for example, look for the logs. From here, we can see the history for that logs. And if I go to the task that performed the scanning on AKS, we'll see here the output, which will be, so here it have detected that some of my resources, they are not implementing the resource limits and the resource requests. Okay. So this is one way to make sure we are respecting best practices in AKS or in Kubernetes. Another way is to use Azure Security Center in Azure. So if I go to here, then jump into Security Center. From Security Center, we have tools that will enable you to scan your resources deployed in Azure to look for vulnerabilities, security issues, best practices, and so on. And those resources could be either virtual machines, or they could be anything that could be SQL databases, or ACR, or Kubernetes clusters, and so on. So you see here in my clusters, I have some recommendations that it tells me. So let's see this one, for example. So here it tells me that I'm not implementing airbag in one of my clusters. So I should take a look into that, and I should re-enable airbag in my clusters, because that's one good practice to implement. Great. So now that deployment was done successfully, this means in Azure we have our clusters already deployed. So if I go to 2023, any of those clusters. Let's see, 21, for example. Here, we would see here the resources already created. Okay, so you see the ACR, AKS, MySQL, the storage account, and the database already created. And the app is also deployed into that AKS cluster. So from here, I have already connected. Let me do that again. If I run here kube control get pods, I'll get the pods that were deployed by my application. And if I run now get services, I'll get the service related to that pod. So remember, those are the YAML files that we are creating. Those have they will create a pod, and they will also create a service for that pod. And the service here, it uses a load balancer. This means that it will be publicly available on a public IP address, which is the one right here. So from here, I can open that IP address, and here I can access my application running in a container in AKS and deploy it from Azure DevOps. Great. So that was the result of running this pipeline. Let me, it takes so much time to run that pipeline, but let me make one change here. Let's say, for example, we want to create more environments. So here I'll change this by 2024, hit save, and then I'll run my pipeline live. So I go to create a new release, create, and then if I open this in a new window, I'll be able to see that pipeline started provisioning. And what this will create, so what we have seen earlier here in the resource groups, those it created resource group 2023. This will now, the new release will create new resource groups or new environments with 2024. So let's give that a few seconds, and once it will finish the deployment, that will create a new resources for us. Great. So let's see if you have some questions.
Yeah, so if we go to the Q&A, there are many new questions. Maybe Houssem, you can switch to that tab as well. Maybe we can start from the latest, just for the context, because a lot of questions came around the last step you were doing. So how can you switch between local and cloud cluster via Q?
Okay, good question. How we can switch between local and cloud cluster? So in my yes, so either I can use here my command line. So if I'm connected to yeah, first thing to do is you need to connect to your cloud cluster. So for that we have the command here. I have run that before, which is AKS get credentials. Okay, and note here, because I'm already connected to my AZ through AZ login. So I'm connected to my Azure, then I can retrieve the credentials for my Kubernetes cluster. Okay, so by running this will connect to AKS, it will retrieve the secret, and it will merge that secret into my kubeconfig file. So here you have the path where to find that file that contains all your configurations. So let me cut that. Oops, and yeah, here to have lots of contents actually. So those are the different Kubernetes clusters I'm connected to. I was doing lots of experimentations. So yeah, so here you have the name of the AKS cluster each time. And then let me go to the first line. And yeah, so this contains the information about the different clusters you are connecting to. So from there, what you can do is then you can use kubectl config, and I forget exactly the command, so let's use -h to help you. So there is kube control config get current context or something, command like this, in which you can use to switch to another Kubernetes cluster. So here it is, set context. And if we try to first run get contexts, so here you'll find all your Kubernetes clusters. One of them is Minikube. That would be your local cluster. And then to switch to that, you would use the command set context. Okay, set context or set cluster to switch to Minikube or to any other clusters here. If you are also using Docker, I don't have it here running, but you can right click on Docker, and from there you can switch to another container. And you can do that also from VS Code. So in VS Code, you have a nice extension developed by Microsoft that is called Kubernetes. And this extension will detect all your clusters, specifically that are hosted on Azure. So if we give this a few seconds, it will display all my clusters. And from there, I can, yes, so you see here the same list of the clusters we have seen before, and we have also Minikube. So if I right click on any of those, I can here select set as current cluster, and I can delete it from my kube config if I want to. So from here, this is what I would recommend to switch from and to different clusters. Other questions. So here, Joe is asking, in your pipeline, are you redeploying ACR, AKS, and SQL DB every time the pipeline is executed? If not, why is it in the pipeline? Yes, good question here. So the question is that in my pipeline, in each time I run the pipeline, it will run the commands for Terraform apply. So what this will do actually, so does this mean that we are redeploying the same resources? Here, the answer is no, because Terraform will detect that I already have deployed that resource before, so it won't change it. It's there in case I have changed some configuration on my infrastructure. So on that time, it will change my infrastructure. Okay. This is to enable that in each time you have a new change in the infrastructure, we'll go to deploy it immediately. So this, in most of the cases, this is not doing anything, just checking if there is no change in the infrastructure, and then it will skip and continue to the other tasks. So if the resource already exists, it won't touch it. It will not create a new one. Okay, another question. Can we have OKD demo, OpenShift Kubernetes distribution next session? Oh, OpenShift, yeah, that's one of the nice distributions, but yeah, maybe, why not? Next sessions, maybe, why not? How would this work if you had multiple containers running in Kubernetes? Would you include the Terraform stuff in each container release? So if you have multiple containers, what you would do is that from your CI pipeline, you would here add multiple tasks for building and pushing an image. So you would have a task for build and push image 1, and 2 other tasks for build and push image 2, and so on. Okay, what you can use otherwise is Docker Compose. So you can use one Docker Compose file that have all your images, and from there you can run Docker Compose build to build all the images in one task, and then you run a command to push all the generated containers into your ACR. Another question: how would we do if we were pointing to another storage provider, for example, Portworx? If we were pointing to another storage provider, so I think this is for Terraform. So Terraform, for saving the state, it supports Azure storage account containers, and it has support for some other providers. I'm not sure for Portworx, if that's supported or not, but you can find that on the Terraform documentation. They provide all the supported providers. Another question, what happens if you lose a Terraform state or if a storage account where Terraform state is saved is deleted accidentally? Yes, so if you lose the Terraform state, that would be a big problem actually. Yes, so a storage account, actually they have a feature for it's like soft delete. So even after you have deleted the storage account, by enabling that feature, the storage account would still there for a certain number of days. So that would help you to recover that TF state. So just don't forget to enable that option. Can we have database in the pod? What is the way to go to persist data? Yes, we have already discussed that. So should we persist the database inside a pod, or should it be hosted in Azure SQL database, a PaaS offer? In most of the cases, what I would recommend is to use SQL PaaS offering, okay? Because with that you would have a better management for the backup, you would have a high SLA, and you will have less headache actually, because it will be managed by the cloud provider for you, and it would have all the security patches and all the recommended and all the best practices already implemented there. So for me, for most of the cases, unless this is used for development or for testing, just go to use the PaaS services for this. What is stateful sets? So that's another Kubernetes resource that enable you to create or to create pods, specific pods for the applications that should persist data, like databases, for example. Why do we use variables.tf when we can store them in the pipeline? Yes, okay, the question is that here I have already some variables in my pipeline, okay? So those are the variables here, and then I'm using Terraform variables.tf in order to replace the from my files by those variables, okay? Yes, actually that makes sense, because in your pipelines, maybe you want to override those values. Remember what we are doing here. So here we have variables that depends on the environment, whether not the same variables runs on my dev, test, or production environment. So I can override the values here. In addition to that, there is this reason, the password. If you use only variables.tf, this means you would put your password inside that file, and it would be seen by all your developers and by everyone who have access to your Git repository, and that's a security issue. So one way to secure those values is to use here the variables from here, and you can add more security, because even here it's seen. I can click on this button to hide that value. And they can even do more, and this is one of the best practices to do, is that you can use Azure Key Vault to save your secrets there. And your Azure DevOps pipeline can connect to that Key Vault in an easy way to retrieve the password for your database from there. So I can show you maybe quickly how that works. So if you go to variable groups, then link variable group, you select release. Let's select this link. If I select this, the variable group, then here I have the option to link secrets from Azure Key Vault. And by enabling that, here it will ask me to connect to my Azure subscription, and then it will connect to my Key Vault, and from there I can retrieve my secrets and all my sensitive data like the private certificates, my encryption keys, and so on. Good. Let me remove this and link. Yeah, great. Another question, can you show the way how to create infrastructure, for example, interaction tests, and after that done to delete infrastructure pods? Yes, so we can create, so here we have already created the infrastructure using Terraform, but we can also destroy this infrastructure. So remember in Terraform, you have this command. One of the commands available here is destroy. And destroy will go to destroy or to delete all the infrastructure that we have provisioned in Azure. It will destroy all this environment. It will destroy the resource group and all the resources inside. So this is useful for creating temporary environments. Maybe I just want to provision an environment where I have a virtual machine. Inside that virtual machine, I want to run some tests. And when I'm done with those tests, I want to delete or to destroy all the environment. So I can do that to save money and also to be able to run more tests as I want. Great. Let's now check our pipeline, and oops, it failed. I think this is because of one of the names that already exists. And now if I go to check on Azure, if I go to refresh my resource groups, I should see here AKS Dev 2024, which was the one created by my pipeline by using Terraform. So here I see another resources created by Terraform. So here I can, with Terraform, it's useful because just by changing the value for the variables, I can create the same infrastructure and I can duplicate it in multiple environments, for example. Great. Can you execute steps in parallel? Not steps, but we can actually we can run the jobs in parallel. So here I have one job, but I can add another job right here. If I click, not there, but here actually, add an agent job. This will add another job. And from here, you can add more tasks to this job. Let's add this one, for example. And then if you have the right to run multiple agents, okay, for public projects, for example, then you can run those two agents, those two jobs in parallel. Let me go to remove this. Yep. Is Aquasec a standard tool for scanning images? Not, I won't say standard, but it's one of the most used tools to scan the images. Actually, Azure Security Center uses in some way, it uses Aquasec to scan the images for us. Twistlock also is supported. So if I go to my ACR, if I select ACR here on the overview page, you would see here Twistlock and Aqua Security. Both are supported and available from the Azure Marketplace. So I can use them here to scan the image each time I have a new image available on my ACR. So those will be staying watching ACR. A new image is an ACR, they will go to scan it and provide a detailed report for the security issues that could be found there. Is it possible to pull the Yammer from the GitHub repo and just import the pipeline on the fly? Yes, that would be possible. So that will, with this, I go to switch, and I know we are almost on time. I go to switch to the pipeline using GitHub. So let me go to here. So in my project here, if I go to GitHub/workflows, from here I have created the YAML pipeline using Azure using GitHub Actions. So let's see this one, for example. And here it's the same pipeline almost as we have created in Azure DevOps, but here using GitHub syntax and using YAML. So I'll trigger this YAML pipeline on each time I have a push on the master branch, or I have a pull request on the dev branch, for example. The jobs I would run this pipeline on an Ubuntu machine, and I would define those environment variables to use, like my AKS name, my ACR name, the resource group, and so on. First thing to do is I'll go to check out the source code into the build machine. Then I'll build the container using the command docker build, provide the Docker file and the required configuration there. Then I'll push into, or I'll log in first to Docker Hub. So for that, I'm using the command docker login. And here I'm not providing the password because in GitHub Actions, we have a nice tool here. If I go to settings, we can save securely our passwords. So here you'll see, if I go to secrets, from here I have defined some secrets available here. So the way to do that, you can either go to add new secret, provide a name, then paste the values. So here I have my Azure tenant ID, the repository password is also a secret here. So I can access those secrets from my pipeline using this syntax right here, the brackets, then secrets, and then dot the name of the secret itself. After that, I can push my container onto Docker Hub, and then I run security scan using scan. Oops, we have lost connection. Okay, and then I'll go here to replace some values in my Terraform folders. Then I'll go to deploy the infrastructure. So I'll run the command Terraform format to check the syntax. Then Terraform init, as we have seen earlier, Terraform validate, and then Terraform plan, and then Terraform apply to start provisioning the infrastructure on Azure. Once that infrastructure is deployed, we go now to connect to our AKS cluster. So first of all, we'll go to use this action called AKS set context. This one will connect to Azure, to our Azure subscription, to our AKS name, and the resource group. And this is the equivalent of get credentials as we have seen earlier. So this will connect us to the Kubernetes, to our AKS cluster. Then once we have connected to AKS, we'll go to deploy the files using the task Kubernetes deploy. So this will deploy those different YAML manifest files. Remember, those are the files that are provided in my Kubernetes folder. Those are the different YAML files described here. Once we have deployed those, so now we'll go to run scan against our AKS using kubadvisor by this command kubectl run the kubadvisor image, and then what will run the scan against the cluster itself. So this is now, this YAML pipeline is saved in my GitHub repository. This means anyone of you who will go to clone or fork this project, he will also get this pipeline already exported. So here, the benefits of doing this, of doing the YAML pipelines, is that we can version control it, we can have different versions, we can reuse it, and we can export it or save it as a configuration for our application. And in each time our application would update, it means if I need now a new database, I would, or if we have new tasks, we can provide those tasks with the YAML configuration files here. Great. Okay, so this was now creating the CI/CD pipelines using GitHub Actions. I will not run this because it would take much time, but yeah, I believe you get the idea. Good. I'm almost done with my presentation. I think it's time to take some questions if there is.
Yeah, there were a few more questions that came. Just to highlight for everyone that is still on the stream, the link, I put it there in the Q&A as an announcement. It will be still accessible for some time, I think for the next 12 hours. So you can use it. If you missed any part and you want to follow along, you can access it. So once we end the stream, the playback will be available right away. And then later
Great.
also we will add it to our YouTube channel. So that will take a couple of days. So if you missed anything, there was a diagram or any part that you want to go back to, the link is already there. I put it again on the Q&A. So you can just keep it. Yeah, that's the diagram. And yeah, the link is there. So there were 5 questions in the Q&A before the link. Houssem, if you want to go through that.
Yeah.
This is the latest that came, and then we can wrap up.
Yeah. Just I'll try if I can. I don't know if I can do this. Just give me 1 second. I try to take screenshot of this diagram and I try to paste it into Teams. Let me try this.
Well, I think we cannot put it on in the Q&A section. It will just go in our own chat. So maybe we can add it in the GitHub itself, or if you can just generate a link just for that file.
Yeah. Okay. I'll try to add it to this repo. Okay, on the right on the root folder. Yeah. Okay. Let's see if we have some questions. Is there a way you can validate your Terraform configuration in the build rather than in the release? Okay, configure the Terraform configuration. Yeah, without doing plan or validate specifically, that will require you to deploy your Terraform into your cloud provider. So I don't know any other way to validate that configuration. Maybe you can do like a dry run, but again, that's like a bit like validate. So that, yeah, maybe doing a dry run that would help. On the build pipeline, you are doing a security scan for the container image on ACR, but if you already have a vulnerability on your image, how you undo the pushing, or should you scan it before pushing the image to ACR? So if the build fails, you can be notified and the registry. Yeah, okay. Yeah, that makes sense. Actually, here we have you can come back to my pipeline. So here we have pushed the image, then we have scanned it on the build pipeline. So if we have discovered here any security issue, the image is already on ACR. So yeah, that's maybe it would be better to scan the image just before pushing it into ACR. And we can even add to this security with Azure Security Center. It have a good feature. If I go to Azure Security Center. So Azure Security Center have a good feature. ACR actually have that feature, sorry. With ACR, what we can do is that we can apply quarantine on the container itself. I don't know where to find these. Retention. So we have this nice feature called quarantine. So this means after that you have pushed a container into ACR, that container would be in ACR and it could not be used by Kubernetes for a specific amount of time. So let's say for maybe 1 or 2 days, the time to run all the scans and to validate that container. Okay, so this adds to the security of your containers. Let's see another question. Sorry if I have question off topic. How to deploy a database with simple migration without using DACPack? Okay, so you can do this using typically using SQL scripts or using entity framework migrations if you are using that, or Flyway if you use Java applications. But yeah, let me see the question from the first. Can you please explain more about links between AKS, Azure DevOps, Visual Studio, if possible related to version control and release configuration? Okay, so Azure VS Code is the code editor that we are using here to view the code files and to connect to Kubernetes through an extension if you want to from here. But Azure DevOps is the tool that runs the CI/CD pipelines. That's the tool we are using here. Okay, so as you see here, dev.azure.com, that's the link to Azure DevOps. So from there, we create the YAML, create the CI and CD pipelines. And AKS is the Azure resource that would deploy my containers. That's what we have, what we was seeing in the resource group right here. So let me go back, resource groups. Here, that's the instance that they have created here, AKS. Okay. But is it dangerous to include Terraform in the pipeline as if may delete and recreated resources, for example, when renaming resources? Yes, yeah, try to avoid renaming the resources because, yeah, that time it's better to test if Terraform will delete that resource and recreate it again, because many services, they don't support renaming the resource. So Terraform, in most of these cases, it will delete the old resource and create a new one with the new name. How do you switch between? Okay. Okay, I think I have.
Yeah, we covered that question.
Yeah, the last question, does it make sense to use Helm with AKS? Yes, thank you. You have provided me for how to use Helm. So here I have sample CI pipeline for how to use Helm. So first we go to build and push the image. Then here we'll go to package the Helm package. So one word about Helm. That's my last point here. So here in this sample application, I have a Helm chart. So if we go to charts here, we have product store, and here we have templates folder, and then we have the mvc.azure.yaml. And see, this is actually, it looks like the same YAML, the same MVC deployment YAML file available here, okay? But with some changes that it have those curl brackets, we call them, with dot values dot namespace. And you see here, each time you have dot values dot then some value. So this means those values will be replaced by values inside a file, which is the values.yaml. So here we have, for example, let's see, for example, here, the namespace. So we have a value called namespace inside that values.yaml file. And here the namespace will be replaced by the value here, Helm namespace. Then for the image, for example, then we have value dot web image docker hub ID. So we have web dot image docker hub ID, and then the value would be this one here. Okay. Then we have web.image.name. This means the value would be this one, the name of the image itself. Then we have .tag, which will replace the tag for our image. And we have lots of this configuration right here. So Helm will help us to package the YAML files and to provide multiple to create like templates for those YAML files, so we can replace values inside those YAML files. So we can deploy those Helm templates into Kubernetes, and that's a bit different than deploying the native YAML manifest files. So here we should use the Helm command line. So from my CI pipeline, I'll go to install Helm on the build machine. Then I'll run the command Helm package. This command will create the package for me. It means it will put all of those folders, all of those YAML files into a TGZ file. It's like a zipped file which contains all my templates. Then I'll pass those into the drop artifact. And from this CD pipeline, now I'll go to retrieve those artifacts. And in the pipeline, I'll go to install again Helm on the build machine because it's not installed by default. Then I run the command Helm upgrade, which will connect to my AKS cluster, and then it will pass that generated package. So this will deploy my application using Helm. Great. I hope that answers your question. Yeah.
Thank you, Houssem, for this amazing session. Yeah, it was great, and we got like 46 questions. We covered a lot. So just a reminder, everyone, the session is accessible on the link that I shared in the Q&A, and it will be later available on the YouTube channel. So I'll also paste the YouTube channel link here, actually. If you go to YouTube and write Reactor Abu Dhabi, you will find the past sessions. The official channel for Microsoft Reactor is called Microsoft Reactor. So I'll paste actually the last session we did together here, if you want to also check that. And there will be more. Can you just yeah. There will be also coming sessions almost every day on the Reactor. So if you check out our calendar of events, you will be able to join the coming sessions. So I'll also post that in the Q&A. Basically, there are sessions almost every day, and some of the interesting ones are on Wednesday, for example, Java on Azure, building a Spring Boot microservices. And then we also have on the next Sunday, we have media content and AI. So that session will be covering basically how to architect and build applications that performs media streaming using Azure services. And of course, we have Microsoft Build coming up on the 19th, 48 hours of very interesting sessions. So make sure you also register for that. All of this is free to attend. The link also is on Meetup. So it's register.build.microsoft.com. And make sure you stay tuned for more interesting sessions coming from the reactors. And thank you, Houssem, again. Just tap and mute, Houssem, please.
And thank you too, and thanks for all the participants and all the attendees who have attended for 2 hours of learning on DevOps, Azure, and Kubernetes. Thank you all, and hope to see you in next sessions.
All right, thank you everyone, and stay safe. Bye-bye.
Thank you, bye-bye.